Can something with zero dimensions actually take up space? I mean, your gut reaction is probably no way, right? How can a bunch of nothings add up to something? But the real answer is a whole lot stranger than you might think. And believe it or not, the key to this whole puzzle is sitting right here in this paper from 1937. It was written by a Polish mathematician named Edward Szpil-Ryin, and the title pretty much says it all: The Dimension and the Measure. He went straight for the heart of the problem. Now, what's cool is how Spielrein starts his paper. He doesn't just jump into a bunch of equations. Nope. He points out this one very specific, very weird situation, a case where our everyday intuition about geometry just completely falls apart. Okay, so he says, imagine a flat 2D plane, like a sheet of graph paper. But here's the twist. We're not going to look at all the points. We're only going to pay attention to a very special set. The points where both the x and y coordinates are irrational numbers. You know, numbers like pi or the square root of 2, those decimals that just go on forever and ever without repeating. And this is where we hit the paradox head on. If you look at this strange collection of points from a purely mathematical perspective, its dimension is 0. It's not a line, it's not a sheet, it's just a disconnected dust of points. And yet, its area, its two-dimensional measure, is actually a positive number. It really does cover a real amount of space. How can that be? So, how is this possible? It feels like it breaks the rules. Well, to figure this out, we've got to act like detectives. We need to investigate our two main suspects and define our terms. So let's ask, what exactly are dimension and measure anyway? All right, first up, our first suspect, dimension. We all have a pretty good intuitive feel for this one, but let's just make sure we're all on the same page. You know, intuitively, we just kind of build dimensions up from scratch. You start with a single point. That's 0 dimensions. String a bunch of those points together, and boom, you've got a one-dimensional line. Stack a bunch of lines next to each other, you get a two-dimensional plane. And then you stack those planes and you've got a three-dimensional solid. Seems simple enough, right? Well, that simple stacking idea works great for lines and squares, but for weird, messy sets like our dust of irrational points, it doesn't really work. So mathematicians, like a guy named Felix Hausdorff, came up with a much more powerful definition. You can think of it like this. Dimension is all about how efficiently you can cover a shape with smaller and smaller pieces as you zoom in. This method lets us calculate the dimension of way more complicated stuff. Okay, so we've got a handle on dimension. Now let's turn to our second suspect, measure. Now, this word might sound a little academic, but the idea behind it is something you already know really well. Yeah, measure is really just the official math term for an object's size. And the best way to think about it is with a simple question.